Hi, my name is San HV and today I'm going to present my seminar on a paper which is presented by the Facebook AI research team consisting of these four gentlemen, Aman Shahlin, Edward Grava, Peter Brozhanovsky and Thomas Miklov. It's called The Bag of Tricks for Efficient Text Classification. So this is an idea of what the paper is about. As I said before, presented by the Facebook AI research team. It's a recent paper submitted on July 2016, later revised in August 2016, and it mainly deals with text classification and provides a simple baseline for efficient text classification. And the abstract goes as follows. The paper describes usage of fast text classifier. For those who do not know what fast text is, it is an open source library which was developed by the Facebook AI research team, can be used for word representation learning and text classification. So these team of people, they conducted certain experiments and they came to a conclusion that the fast text classifier built using shallow neural networks was in par with deep learning classifiers in terms of accuracy, but was also faster in terms of training and testing. So they claim that the fastest can be trained with more than 1 billion words in less than 10 minutes on a multi-core CPU and classify almost half a million sentences among 312,000 classes in less than 1 minute. So what is text classification? It is an important task in natural language processing with many applications like you can say sentiment analysis, information retrieval, document classification, web search, and stuff like that. So recently, what happened? Models with neural networks that all deep learning, there's layers and layers of neural networks have become popular because they are really fast. So even though they're fast, because of the layers, the work is divided between the layers. They take a lot of time to train and test. So what in test classification, first we need to train the classifier with some data and then test it on some data as well. So since it has to go through layers, the training and testing time takes a long time, so it proves to be a problem. Well, linear classifiers, there's only one layer, so they are pretty efficient in text classification, right? But when it comes to large corpora of text, linear classifiers may take a long time as well, even the accuracy. So what is the architecture of the fast text classifier? It's built on top of linear models using shallow neural networks. That means only one layer of neural nets, hence it is linear. So what this does is, the unique feature is, it learns the word representations rather than the word itself. So the word representations can be averaged into a sentence representation and fed into a classifier. And a softmax layer is used as a mathematical function to obtain distribution over classes which are already there, and the complexity is OKH, where K is the number of classes, H is the dimension of the text. Like I said here, each one x1, x2 to xn are the word representations which are averaged in a hidden layer, get a sentence representation to give an output. So fast text libraries, so these are open source and the classifier uses three of them: the supervised, test, and the predict. What the supervised does is, this is used for supervised learning. So this command, it is used to train with examples of text, and the output is a binary file which converts all those words into vectors in an n-dimensional space. So it forms a training module which is a binary file. Test, this feature enables testing of the remaining part of the test, and this uses the binary module from the previous stage, that is the training stage. And predict also uses a binary module, predict unsupervised data as well. So supervised is used for training, test is used for testing, and predict is used for unsupervised learning. This is a training stage. Like I said, input data set divided into training and testing set. Training fed into the classifier to get a training module. Testing stage, you use the training module, and the testing side feed in a classifier, get the accuracy of the classifier, like how well it is able to classify text. Okay. Right. Previous. Yeah. So okay, n-gram features. So what this classifier does is, it takes a lot of words together, Like if you take one sec, if you take one word together, like over here it's called a unigram. If you get two words together, it's called a bigram. Whereas the fast text classifier, well, it takes n-grams. It gets entire sentences together, and the weight of that is fed into a mathematical function, and whether it leans to, suppose it's sentiment analysis, whether the entire sentence leans towards positive or leans towards negative, it's averaged over that, and you get a particular label. Like suppose it's positive, you get label 1, negative, you get label 0. So n-gram dictionary, when it's formed, it does take a lot of space. So it may, to conserve space, use a hashing technique. So a hashed n-gram dictionary makes it incredibly fast. And the experiment, so FastText benefits by using n-grams, and it outperforms character CNN and character CRNN, which are convoluted neural nets and convoluted recursive neural nets, and performs a bit worse than the VD CNN. These are the classifiers called by other papers as well. So these are the two things that they've used fast text classifier to do. One is the text classification. Given a body of text, it says, yeah, this is an artistic work. And then tag prediction. All this Twitter and other social media use tags, so reading a block of text, it's able to predict its tag as well. So this is sentiment analysis experiments performed. So as you can see, these are the various data sets on the left hand sides. There's Yelp, there's Amazon, Yahoo, there's Sogu, AG. Okay, as you can see, the character CNNs and these other classifiers which are used coined by these papers, Zhang and LeCon and Conyu in 2016, they take roughly what, like you take the Amazon polarity dataset at the end, it takes 2 days and 5 days for the CNN to train against them, while it takes around to average 5 hours for this other classifier, whereas the fast text, which uses a bigram, takes only 10 seconds. This is how fast text classifier is. Okay, and this is, I think, the tag prediction. Yeah, so even here you can see the time as tag space, which is a commonly used classifier for tag prediction. It takes around 6 hours and 15 hours. This is able to do in matter of seconds, or at max 1.5 minutes. It's really fast. Okay, this is what tag prediction is. On Flickr data, suppose you have headings for some of the pictures, it is able to give it a tag. Okay, so we come to the end of the paper. The FastText, what it does, it outperforms many recently proposed models which run on deep neural networks. And although deep neural networks, they are supposed to be state of the art, they are really accurate, they are pretty slow. So this could be a solution in the future where speed and accuracy are kept intact. So obviously nowadays the influx of data and the volume of data on the internet is becoming bigger and bigger, so you need faster computation, you need faster things. So this may prove useful in future NLP applications. Thank you.